Hey everyone, welcome to this explainer. Look, if you've been studying Python and you're gearing up for interviews, you really need to know exactly what interviewers are looking for. So today we are transforming a comprehensive guide on the absolute most frequently asked Python interview questions into your ultimate roadmap. We're going to use a categorized pyramid approach, breaking down everything from the bare bones basics all the way up to deep under the hood architecture. Let's conquer your next interview. Okay, let's dive right into this. We are grouping over 25 rapid-fire interview questions into 5 logical levels: Python basics, data and control flow, functions and exceptions, object-oriented programming, and finally, advanced and performance concepts. Let's start building. All right, starting at the foundation, level 1, Python basics. Right out of the gate, when someone asks, what is Python? You definitely don't want to just say it's a coding language. You got to let them know it's a high-level, interpreted, dynamically typed language. Really nailing how standard variables and basic data types, things like integers and strings operate, well, that just sets a rock-solid foundation for the rest of the interview. Now, what's really interesting here is that interviewers absolutely love testing your historical knowledge. Like, do you know how many keywords exist in Python? Well, it actually depends on the version. Understanding the structural differences between Python 2 and 3, like how print evolved into a function, or the nuances in integer division, that proves you've got deep foundational knowledge, not just rote syntax memorization. Moving on, let's talk environment and execution. Virtual environments are absolutely crucial for isolating your project dependencies. And why exactly do we call Python dynamically typed? It's because type checking happens at runtime, meaning your variables can literally change types on the fly. And oh, that famous if underscore name is underscore main line? It's a classic question. It simply checks whether your script is being run directly or if it's just being imported as a module. Moving right along, we hit level 2, data and control flow. This is a big one. Lists, tuples, sets, and dictionaries, these form the absolute core of how we store data in Python. Picture it like this. Lists are your flexible, mutable go-tos. Tuples, they're locked down tight, totally immutable. Sets stitch any sort of order in, just to guarantee uniqueness. And dictionaries, well, they store data in those incredibly powerful key-value pairs. Okay, get ready for a classic trick question. What's the difference between the is operator and the double equals operator? It sounds simple, but it is super vital. Double equals just checks if the actual values are the same, whereas is checks if they point to the exact same location in memory. Huge difference under the hood. To actually manage your logic, you're going to need control flow statements. So break will completely snap you right out of a loop. Continue, on the other hand, just skips the current iteration and forces the next one to start. And pass, well, it does absolutely nothing. It's literally just a structural placeholder so you don't get hit with syntax errors. When it comes to loops and iterations, just remember that for loops iterate over sequences, while while loops keep running until a specific condition turns false. Oh, and the range function? That is going to be your best friend for quickly generating numeric sequences. And definitely don't forget your operators, specifically floor division. Using those double slashes handily chops the decimal right off your result. Stepping up the pyramid, here is level 3, functions and exceptions. Let's see how this builds our architecture. What's the real difference between a module and a function? Basically, a function is just a single block of code designed to do one specific task. A module, though, is an entire Python file. It contains multiple functions, classes, and variables, and it's designed to help you scale and organize your whole code base. You're also going to need to know about anonymous, or lambda, functions. As the name implies, they don't have a name. So why use them? Well, they are absolutely perfect for short, throwaway operations where you just don't want to formally define a full function. This is especially true when you're working with built-in tools like map or filter. Look, code breaks. It's just a universal truth of programming. When an exception pops up, Python relies on try and except blocks to gracefully catch that error so the whole program doesn't just crash and burn. If you pair that with knowing how to safely open, read, write, and close external files, your scripts are going to become incredibly robust. All right, we're getting into the architectural phase now. Level 4, Object-Oriented Programming. So, as we dive into OOP concepts, let me ask you, if you see the word underscore, underscore, init flanked by those double underscores, do you know exactly what it represents? You probably guessed it. It's a constructor. But definitely don't stop your answer there. A constructor is the specific method that gets automatically called to initialize a newly created object's state right at the exact moment it's born. Next up on the OP docket is polymorphism. The two core pillars you need to grasp here are overloading, which is using the same method name but with different inputs, and overriding, which is where a child class completely redefines a method that it originally inherited from its parent. To really wrap up OOP, you have to master inheritance. Basically, this is a mechanism where a new child class absorbs the properties and methods of an existing parent class. It is a total game changer because it drastically reduces code repetition and helps you build a highly logical, hierarchical structure. And now, welcome to the top of the pyramid, Level 5, Advanced and Performance Concepts. So the crucial point is, at the senior level, you absolutely must understand the Global Interpreter Lock, or the GIL. Long story short, the GIL is a mutex that allows only one thread to hold control of the Python interpreter at a single time. This deeply impacts multithreading and memory management. Showing you know this proves you understand the actual engine of the language. Now, let's look at your pro-level toolkit. First, decorators. These are amazing because they brilliantly wrap a function to extend its behavior, but without permanently modifying it. You also need a solid grasp of multithreading to run tasks concurrently. And crucially, really importantly here, unit testing. You have to prove you can systematically test your own code before it ever even thinks about hitting production. As your interview wraps up, you might get hit with a seemingly simple yes or no question. Can we improve the performance of Python code? Gotta be careful here. Answering yes is kind of a trap, but it's a good trap. Because if you say yes, I guarantee the interviewer is going to demand examples right on the spot. Whether that means swapping out lists for sets to get those faster lookups or properly utilizing built-in functions, continuous optimization is the ultimate mark of a true Python master. Well, thank you so much for joining me in this explainer. As you prep for that next big interview, I want to leave you with this. Which of your old Python scripts are you going to optimize first?